Description: create a Python project using a virtual environment. A virtual environment provides an isolated environment for your project, preventing dependency conflicts with other projects on your system. This allows you to manage dependencies and packages for your project separately, ensuring a consistent and predictable development environment. Use cases: project development with isolated dependencies. This ensures that your project's dependencies are independent from your system's Python installation and other projects, reducing the risk of conflicts. Deploying and running the project on different systems. Since the virtual environment packages the project's dependencies, it ensures that the project can run consistently on different systems with different Python configurations. Inputs: project name, the name of the project directory. This will be used to create the project folder in the virtual environment. Dependencies: a list of dependencies, packages and libraries required for the project. These can be specified during virtual environment creation or later using a requirements file. Version: the Python version required for the project. This can be specified during virtual environment creation. If not specified, it will default to the system's default Python version. Outputs: project directory, a folder containing the project's source code and files. Virtual environment, a directory containing the isolated Python environment with all necessary packages and dependencies for the project. This directory usually includes a bin directory, which contains the Python interpreter and scripts for managing the virtual environment. Requirements file: a text file that lists all the project's dependencies and their specific versions. This file can be used to easily recreate the virtual environment on different systems. Commands: mkdir project name, create a new directory for the project with the specified name. cd project name, navigate to the newly created project directory. Python 3 mvenv venvn, create a virtual environment using the venv module in the Python 3 interpreter. The virtual environment will be created in a subdirectory named venv inside the project directory. Source: van vinactivaten, activate the virtual environment. This modifies your system's path environment variable, making the virtual environment's Python interpreter and packages available for use. Steps: 1. Create a new directory for the project. This step creates a dedicated folder for your project, keeping the project's files and code organized. 2. Navigate to the project directory. This step changes your current working directory to the newly created project directory, ensuring you are working within the project context. 3. Create a virtual environment. This step isolates the project's dependencies, preventing conflicts with other Python projects on your system. The virtual environment is created within the project directory and contains a separate Python interpreter and package management system. 4. Activate the virtual environment. This step modifies your system's path environment variable to point to the virtual environment's Python interpreter and packages. This ensures that you are working within the isolated environment and that the project's dependencies are used instead of the system's default Python installation. 5. Install project dependencies, optional. This step installs the necessary packages and libraries required for the project. You can either install them individually using the pip package manager or use a requirements file to install multiple dependencies at once. 6. Start developing your project, optional. Once the virtual environment is set up and dependencies are installed, you can start developing your Python project. The virtual environment ensures that all necessary packages and versions are available for your project. Challenges and fixes. Virtual environment creation failed and install Python 3 and make sure you have Python 3 installed on your system. You can check if Python 3 is installed by running the command python 3 version in your terminal. If you don't have Python 3 installed, you can download and install it from the official Python website https://python.org downloads. Virtual environment activation failed and source the activate script and make sure you are running the activate script from the correct location within the virtual environment directory. The correct path is typically van winactivate. You can also try running the command in a new terminal window to ensure that the environment variables are properly set. Dependencies installation failed and ensure network connection. Check your internet connection. The pip package manager needs an internet connection to download and install packages. Dependencies installation failed and update package manager and ensure your pip package manager is up to date by running the command python 3 pip install upgrade pip. Dependencies installation failed and specify correct package names and double check the names of the packages you are trying to install. Make sure they are spelled correctly and that you are using the correct case, e.g. requests vs requests. Dependencies installation failed and specify correct package versions and if you have specific version requirements for your packages, include the version number in the installation command. For example, pip install requests 2.28.1 will install version 2.28.1 of the requests package. Dependencies installation failed and check for package conflicts and if you encounter errors during installation, there might be conflicts between the dependencies you are trying to install. You can try installing the packages one by one to identify the source of the conflict. Dependencies installation failed and install packages one by one and if you are experiencing issues with multiple package installations, try installing the packages one at a time to troubleshoot any conflicts or errors. Project structure not defined and use a package manager to define dependencies in detail in PE. Same class and use a package manager, e.g. pip, to manage dependencies within your project. This allows you to define the packages and their versions in a separate file, usually requirements.txt, making it easier to track and manage dependencies for your project. This also helps ensure consistency across different development environments and ensures that all necessary packages are installed for your project. Description: a system that tracks changes to files over time, allowing for collaboration, versioning, and history tracking. Use cases: source code management for software development, document collaboration for teams working on shared content, configuration management for infrastructure and settings, tracking changes in research data, versioning creative projects like art or music, maintaining historical records and archives, inputs, files or directories containing code, documents, or other data, commit messages describing the changes made, branch names to organize different lines of development, tags for labeling specific versions or releases, merge requests for combining changes from different branches, outputs, version history showing all changes made over time, diffs between versions highlighting specific changes, merged files representing the combined changes from multiple branches, release tags for identifying specific versions, branch history for tracking the development of different features, commands, basic commands, add stage files for inclusion in the next commit, commit record changes to the repository with a commit message, status show the current state of the repository and changes, Log view the commit history. Diff show differences between versions of files. Remote commands. Push upload local changes to a remote repository. Pull download changes from a remote repository to the local machine. Fetch download changes from a remote repository without merging them. Branching and merging commands. Branch create a new branch for a separate line of development. Checkout switch to a different branch. Merge combine changes from different branches. Rebase reapply changes onto a different branch. Other commands. Reset undo changes and revert to a previous commit. Revert create a new commit that undoes a previous commit. Stash temporarily store uncommitted changes. Tag label a specific commit with a tag. Steps 1. Initialize repository. Create a new version control repository to start tracking changes. 2. Stage files. Select files or directories to be included in the next commit. 3. Commit changes. Record the staged changes with a descriptive commit message. 4. Push to remote repository. Upload local changes to a shared repository for collaboration. 5. Pull changes from remote repository. Download changes from the remote repository to keep the local copy updated. 6. Merge branches. Combine changes from different branches to integrate features or resolve conflicts. Challenges and fixes. Challenge merge conflicts. Fix resolve conflicts manually by carefully comparing changes and choosing the correct version. Challenge lost changes. Fix use a backup of the repository or revert to a previous commit to recover lost data. Challenge branching issues. Fix follow a consistent branching strategy or rebase branches to maintain a clean history. Challenge security vulnerabilities. Fix update to the latest version of the version control system and its dependencies to patch vulnerabilities. Challenge performance issues. Fix optimize repository size by removing unnecessary files or use a faster version control system like Git. Challenge collaboration issues. Fix use a shared repository for team members to work together or establish clear communication. Channels. Challenge integration issues. Fix use a continuous integration, continuous delivery CI/CD pipeline or integrate with other development tools. Challenge data corruption. Fix use a backup of the repository or restore from a previous version to recover from data corruption. Challenge scalability issues. Fix use a distributed version control system like Git or a larger server for handling large repositories. Challenge accessibility issues. Fix use a web-based interface for remote access or a mobile app for on-the-go access. Challenge usability issues. Fix use a user-friendly interface or provide documentation and training to improve usability. Challenge cost issues. Fix use a free or open source version control system or explore cloud-based solutions with different pricing tiers. Challenge legal issues. Fix consult with a lawyer or review the license agreement of the version control system to understand legal implications. Challenge ethical issues. Fix consider the impact of the version control system on individuals and society, including data privacy, intellectual property, and responsible use of technology.